Hi guys, welcome to today's video. Sorry, I'm eating some candy. My bad. So we're going to do the interim review. We're going to do page 4 tonight. That is this one. Okay. So this says, which expression shows 0.61 times 10 to the 12th power expressed in proper scientific notation. So remember, when we talked about scientific notation, we said the coefficient, the number here, has to be a number between 1 and 10. Now this number here is not between 1 and 10. It's less than 1. So the decimal, if it were in the correct spot, it would go here, between the 6 and the 1. So that eliminates answer choice D, for sure. However, when you move the decimal, it changes the exponent, right? So when you move the decimal 1 to the right, you're making the number, you're changing it from 0.61 to 6.1. So you're making the number bigger. So when you make the number bigger, then you need to make the exponent smaller. So make the number bigger by 1, then you make the exponent smaller by 1. So we made the number bigger by 1 space, so we make the exponent smaller by 1. So 12 minus 1 is 11, so that's 6.1 times 10 to the 11th power. That is the correct scientific notation for this number, okay? You could have also done it like this, 0.61 times 10 to the 12th power. The positive 12 tells you to move the decimal 12 places to the right. So that's like this. 1, 2, 3. All the way over here. Let's fill in the scoops with zeros. That's actually this huge number. So it's 6, 1, and then 10 zeros. Okay? You could do it like this and then put it back in scientific notation. So your decimal needs to go here. Okay, so 1, 2, 3. 11. So that gives you 6.1 times 10 to the 11th power, if you did it that way. Okay? Same thing here. Which expression shows 23.7 times 10 to the 5th power expressed in proper scientific notation? So 23.7 times 10 to the 5th power, the positive 5 tells us to move the decimal 5 places to the right. 1, 2, 3, 4, 5. Fill in the zeros. So that number is 237. 2,370,000. So the correct way to put this in scientific notation would be to move the decimal right here. Okay? So it needs to move from here all the way over here. 1, 2, 3, 4, 5. That's 6 times. So it's 2.37 times 10 to the 6th power. That's what it should be, and that's A. Okay, number 9, which shows 20,010,000 in scientific notation. So remember, you need your coefficient, your number needs to be between 1 and 10. So right now the decimal's here, right there, and we need to move it to the right of this 2. So that'll be 2.0. Or 2.001. Okay, so we need to move it 1, 2, 3, 4, 5, 6, 7 times. So that's 2.001, because you can't forget about the 1, times 10 to the power of 7. So remember, this is a super big number, So when it's a big number, like not a small decimal, then you make the exponent positive. So this one, they tried to trick you because they made it negative. But negative would be if the decimal was over here. Okay? So this one is a positive exponent, D. Okay, what is 73,200,000 in scientific notation? Again, your decimal is currently here. It needs to go here. So you're moving it, and this is, again, this is a really big number, 73,200,000. So your exponent will be positive. 1, 2, 3, 4, 5, 6, 7. So 7.32 times 10 to the 7th power. That's C. Okay? According to the Bohr model, the radius of a hydrogen atom is approximately 5.29 times 10 to the power of negative 11 meters. What is this number in standard form? Okay, so your exponent here is negative, so that means it's going to be a teeny tiny little decimal number. That means you can pretty much rule out these huge long digits here. You can rule out C and you can rule out D, because these are not small numbers. It's either A or it's B. So it's 5.29, and the exponent is negative 11. So that means we need to move left 11 times. So here's 1, 2, I'm going to try to make them really small. Okay. So there's only a difference by 1 0, so you have to be careful. So it looks like when I move the decimal 11 times, that means I added 1, 2, 10 zeros. Let's look at B. Starting by where the 5 is, we have 1, 2, 11 zeros here. Ten zeros here, so it's A. Whew. Those were very close to each other. Okay, the radius of the Earth is approximately 6,370 kilometers. What is that distance in scientific notation? So 6,370. Right now your decimal's here. It needs to go between the 6 and the 3. So you move it left 3 times. Now this is a big number, right? The radius of the Earth, that's a big number. So the exponent will be positive, and the exponent will be how many times you move the decimal. How many scoops did you do? You did 1, 2, 3 scoops. So your exponent will be 3. So 6.370 times 10 to the 3rd power, which is C. Okay? Alright guys, so that was the homework for tonight. It was just those quick little problems. Hopefully you understand it and you can come to class with like some questions if you did it. And I will see you tomorrow.